After building our concept and understanding of the tools of project appraisal, now we are going to execute some tools using some numerical values. Before we begin, we should know that there are a number of tools that we use in project appraisal to come up with some numerical values that we can interpret and guide the decision makers if they should undertake a certain project or not, the calculations of which we have done. So these are the tools that are known as the measures of project worth, but once we include the element of discounting in them, they are known as discounted measures of project worth. In an acronym, I can write it like this. And as I told you that these are more than one tools or measures or techniques. This is why we are going to do the first one today, and we will go ahead as we learn this, and definitely we'll be learning the next one as well, and so on. So we start with a certain example given in the Planning Manual 2015, Government of the Punjab, Pakistan. There is a manual which is downloadable from the internet, and in that they have given this project, which is Lahore Sialkot Motorway. Some hypothetical figures are taken, and these values are actually tabulated in this table that you can see. And before we get to the table, we should know that these values are in billions of Pakistani rupees, and this discount rate is 12%. As we have mentioned, that these are the discounted measures of project worth. So in this first measure, the name of which we haven't discussed, because we will discuss it at the end once we solve it. So the discount rate is given, and usually it is given. If it is not given, we can consider it equal to 12% in case of Pakistani projects, because in case of Pakistan, this is mandated by the planning machinery, that is Planning Commission, and usually it is 12%. So if it is not given, we can assume it to be 12%. But if it is given, for example, 15% or 5% or any other value, then definitely we will use that value. We will also talk about this and the psychological or social reasoning of why there is a discount rate, and as we go ahead. Primarily, we will build this table in which the first column is, in Roman system, this is the first column, second column, third, fourth, fifth, and the following column. In the first one, we are mentioning the year, and it is represented with T. As we develop a certain formula of discounting, we will use this symbol, that is T. The values, they are starting from 1 and they are ending at 10. So it means that 1 year has passed, and 2 years have passed, 3 years, or the 4th year has passed, and here the 10th year is passed. So it is showing the completion of the time period. Usually it is years. It can be less than years, that is in some months, maybe quarterly, biannually. It can happen. But usually, since the record of the economy or the accounts, they are usually discussed on annual basis, or analyzed frequently on annual basis. That is why we are considering it in annual basis. But definitely we have the liberty to use different time scale, that is biannually, quarterly, etc. So let's talk about the values. The first element is of capital cost, and the second element is of operation and maintenance cost. I'm saying element because these are two possible components of the cost, and the first one is represented with acronym CC, and the other is represented with O&M. Capital costs are those costs that are usually spent in purchasing or developing the infrastructure or machinery as the project um, requires, or land for agricultural projects. So you see, these are the costs that are incurred to buy major components of the project. They can be in agriculture sector or in industrial sector or any other transportation related sector. So in the beginning of the project, one can expect large expenditures because this is not 20 pkr, this is 20 billion pkr, which is definitely a large amount. And it is happening for first 3 years. It means that the project is still in the process of construction till the end of the third year. And afterwards, you cannot see any value because it is absent, because the project is now constructed, I should say, and there is no need to construct it again and again. Definitely, it is constructed once. So this area is showing the blank set of values because capital expenditure is now made. And in front of this, the operation and maintenance cost is 0, and that is also logical because if the project is not completely constructed and if it is not operational and it is not working, then definitely there will be no need for operation and maintenance cost. But at the end of the third year, as the project is constructed and it is starting to function, we can say that operation and maintenance cost will start happening from this year. So after summing these two, we will get the gross cost, which is definitely the sum of the two. As you can see, you can verify the calculation and see if there is any mistake. However, it seems correct, and this is the sum of this column and that column. Now we have developed the cost column, and it represents that initially there are capital expenditures, capital costs, and these are recurring costs or the maintenance and operation costs, because these are smaller in magnitude because the project is developed and we are just spending cost to operate the project and keep it maintained, as the depreciation can also happen in the process of operation of the project. So benefits, they are also showing some relevance to the initial phase of construction. Till the first 3 years, there are no benefits, and definitely once if the project is not completed and it's not constructed, we cannot expect any benefits. But as the 3 years pass and the project gets constructed, the benefits, they start to accrue because of the operation process of the project during the 4th till the 10th year. So we can see that the benefits, they are increasing, so it's an encouraging sign. Depends upon the project if the project is giving constant benefits or increasing or decreasing or thoroughly varying benefits. So now we have these two major variables on the basis of which we can calculate the net benefits, as we know that the net benefits are actually the sum of the B's and C's. So it is very easy to calculate this column. 0 minus 20 is minus 20, and this happens in the next two column and next two rows. And let's verify it from the last row, that is 50 minus 7, it will be equal to 43. So now we have another column which is net benefits column. So in the first year we have a loss, a kind of loss I would say, because it's a development project, so loss is not there in its very usual connotation, because loss and profit is the concern of a private sector firm or a private sector project. Here we are talking about the public sector development project, which is trying to deliver some goods or services, and the service delivery is the basic objective and not to make profit. However, we can say that the costs, they are greater than the benefits in the first 3 years. But afterwards, since the benefits they started to accrue, the benefits, they are now greater than the cost, and the net benefits are showing positive values, as here the B's are greater than C, and here the benefits, they were less than C. So in this way, the structure format is visible that the negative values will occur in the beginning of the project, and it is likely that the positive net benefits will happen in the remaining of the years. Now, this was the situation on yearly basis, but we have to come up with an overall value of the project, because we have to give one value to see the overall health of the project. So we have a simple process in which we can vertically add them, and here you can see we have vertically added them, and the answer is 146.50 or 0.50, which is suitably known as the net value, because it's a value, and it is the net value because we have done the subtraction, that is B minus C. So it is the net value, and since it is positive, it is desirable to undertake this project as per the recommendations coming out of this value. So as per this calculation, we can say that the project is desirable. However, there is a caveat here, because when we talk about future, our assignment to a certain value of a certain good or resource, it decreases over time. Let us assume that we are offered something that we value, a vehicle for example, and if it is offered today, and another option is that it is offered to us tomorrow, or maybe after 6 months, or maybe after 1 year, and the next option is that it can be offered to us after 2 years, and then another offer is of after 3 years, and so on. So the natural reaction or the gut reaction that we will have is to have it now. Keeping other things constant, we are going to prefer the vehicle today, because it's a natural thing that human beings prefer today's consumption to tomorrow's consumption. If we have some resource, if we are likely to get some resource, we would prefer to consume it today, because man is mortal and he faces uncertainty in his life, and due to his very nature of being desirous of material things, he would like to have the resources now, and the sooner he gets it, the better he feels, the greater the utility he feels from that good. And if the that good or service gets delayed, the utility declines. It's a natural thing. We would like to have the things we value today rather than having them anytime in future. So in other words, what we are trying to say is a psychological phenomenon that exists in most of the human beings. We prefer today's consumption over tomorrow's consumption. Same resource today is of more value in our preference than tomorrow. We prefer to have the things today as compared to tomorrow or any other time in future. The more we go in future, the more the time passes, the lesser the value will be in our mind of that certain good. And let me repeat that it's the value in our mind. The thing is the same no matter we get it today or after 1 year or later. Thing is the same, but our utility from that decreases if it gets delayed. So if I want to make a graph to make this thing clear, this is time and this is the value of that resource. This is now, that is 0. If we get it, we will get maximum possible utility from that. But if we get it after 1 year, in our opinion, its utility will be less, or its value will be less. And if it gets further delayed, we will not be as much desirous as we are today, and this will happen as we go ahead in time. The more it gets delayed, the lesser will be the utility of that resource. So um, if we are offered this thing, we would like to have it now as compared to any other time in future. So if I join these lines, it is roughly giving me an idea that the value is decreasing as we are going ahead in time. So this phenomenon is visible, and we can call it discounting, because in discounting we are avoiding a certain fraction from counting, so the value declines, and it is visible in this diagram. So the question is that how much should we discount? What is the formula? Let me tell you about that. The discount rate, in this case, it is given, and if it is not given, we can consider it equal to 12% in case of Pakistani projects. But definitely in different countries it would be different, and even in Pakistan the projects would be having different values of discount rate depending upon the situation, because at times some projects are funded by international financial institutions or agencies, and they can assign a different discount rate in case of that project, because they are different stakeholders and they have their own technical and practical opinion about what should be the discount rate. So at this level we are assuming that it's 12%. If it is given, definitely it's a good thing, otherwise we can assume it to be 12%. So 12% is not going to allow us to get this discounting. We have to come up with a formula in which we get a factor, because this is a percentage. A factor is less than 1. For example, 0.9 is a factor, and 0.8, and then 0.9, point, all those smaller values. For example, 0.1 is also a smaller value. So if we multiply such a set of values with a certain series, as we saw in the previous slides, this one, it can reduce the value gradually. So this we will see as we go ahead in the next slide, but I'm just giving you this rough idea of why we are interested in a factor. Factor is less than 1, and when we multiply something less than 1 with something else, it will eat away that value. For example, if it is 0.5, it will reduce the value to half. So discounting will happen, and that is something we want. So let's come to this formula, which is devised, which is well established. 1 plus I raised to the power t. So it is 1 over whole 1 plus I raised to the power t. We insert the value of discounting factor, and we get this value. Since it is a factor and it is based on discounting rate or discount rate, this is rate, let us be clear that this is the discount rate, and this will be the discounting factor. So their names are as they are. So let's see how we can include the discounting factor in our analysis. It is easy to understand this next table, because it is the same table. The first column, second column, and then net benefits, all of these columns are the same, and the number of the years are also same, they are 10. The innovation in this table is the discounting factor that we just understood, and we found the value of discounting factor for all the years, that is 1, and we are substituting 1 here, and for the second year we are substituting 2 here, and in the same way we are going all the way down to the final year, that is the 10th year. You can do this simple calculation, and once you solve this, you will see that the answer is reducing as we are going ahead in time. And this is what I said to you, that the value will decline as you saw in this table, in this graph. And this is the very gist of discounting, that it reduces the value, and as we go ahead more and more in time, the value will decline. This is 1 in Roman system, which is showing that the column value 1 will be substituted here. Actually the variable is t, but that was 1 in Roman system, showing that it was the first column. So this value is now obtained, and now since it's a factor gets multiplied. So we multiply this factor with the net benefits and we get this value. And suitably we can call it discounted net benefit, because it is the net benefit but now it is discounted. And definitely we represent it with D and B, that is discounted net benefit, that it is that version of the net benefits which is discounted. And the value is actually discounted because it was minus 20, but now it is reduced in terms of magnitude to minus 17. So the magnitude, excluding the negative sign, is reduced. Then again 20 becomes 15. Now you can see that the same 20 is reduced to 15 in terms of magnitude, and then again further 20 reduces to 14. So it is the same, the net benefit is the same, but the discounted net benefit reduces as we go ahead in time. So this is what I informed you about, that discounting factor will decrease, and when we multiply it with values, definitely it's going to eat them away. And then 16 is getting multiplied with this term, and the answer will be this. So these are the two values getting multiplied and we will get this answer. So you can calculate this column, it's simple algebra. And just to be sure, this is the final value which will be multiplied with this, and we will get this answer. So I see 43 is now reduced to 13, and the effect of discounting is very significant here, because it is 43 and now it is just 13. So you can see a major decline in the value. Why? Because the discounting factor is now reduced to 0.3. Initially it was 0.89, but now it is 0.3. So the smaller the discounting factor, the greater will be discounting effect. You can see the discounting effect is substantial. It is also in lines with the reality, because you know this 43 will be reduced in value in our opinion. This 20 is negative. Even though it is negative, it is still 17 in terms of magnitude, but it is 43 in future, and it is positive, but it has declined to 13 instead of this value, which was actually 20. So what you see is the effect of discounting. It increases as we go ahead in time, because the more the thing gets delayed and goes into the future, the lesser we will be preferring it. This is why discounting is greater. If we prefer this 20 as compared to that 20 and that 20, this 20 is 17, okay, this is 15, lesser, okay, and this is definitely having the least preference, because the more we go into the future, the lesser will be the preference and desirability. So this is that net value that we calculated before. It was positive, it is good, but now once we sum these discounted net benefits, we will get 41.23, which is substantially smaller than this value. I'm using the sign less than, and it is correct because it is trying to represent the true value. Because 146 was undiscounted, let me write this. we were not including that time preference behavior which is there in every human being. In reality, since we are talking about time in future, this positive value, that is 146, is not as big, and it is lesser in value, that is 41. 41.23 is a realistic estimate, and this is not a realistic estimate because it overlooks the time preference. Here we are considering the time preference, and this is something that we should depend on. One must say that it is an overestimation of the value. So it is better not to overestimate the value, and it is better to come up with a realistic value so that we guide the decision makers in a better way. So we would be depending on this value, and its value is not just net value, it is net present value, because present is something that we use when we discount a certain um, series of values. For example, if we are trying to do analysis, an individual is here, right, and he is analyzing the future, so he is in present, he is in now, and he is looking at the future trying to come up with the decision. So since he is here in present and trying to make the decision in present, this is why we discount, and the value is now known as the net present value. The element of net is there, the difference of benefit and cost, it is there, yes. In the background it is the net benefit, though discounted, but it is actually discounted, so we use the word net present value. Now there is another good property that we can apply on this situation, and that is the distributive property on NPV. Distributive property, as you know, is simply that if there is a factor that is composed of two values either subtracted or added, if we multiply it with another factor, it will be distributed and will be multiplied with both of the terms. So it holds in the case of net present value, and let me see that discounting factor, it is being multiplied with the net benefits. In the last column you saw that we were multiplying the discounting factor with the net benefits, so it means that net benefits can be written as B minus C because it is B minus C. Now we are borrowing this and we are trying to apply the distributive property. Discounting factor into B minus C means that if I multiply the discounting factor inside, it will be appearing with both of the terms, that is B and C, but separately. So here what you can see is that the difference is taken first, that is the net effect is taken first, and then it is multiplied. Whereas here both of these terms, they will be multiplied here and then here, and then they will be taken a difference, and then the net effect will be taken. So in suitable terms I can say that here netting is before multiplying, we are taking the difference first and then multiplying, but here netting is after multiplying, that is we are taking the difference, but primarily we are multiplying these two values and then we are taking the net effect or taking the difference. Above in the table we used this methodology because we calculated the net benefits primarily and then we discounted them. If these are the two sides of equality, this can also be true. So in this case I will try to multiply the discounting factor with the benefit separately and the costs separately with the discounting factor, and then I will take the difference. The answer should be the same. So let us experiment this thing here. The same table is taken. These are the columns that we have seen before. Discounting factor is something we have understood before, but here we are taking the discounted cost separately and discounted benefit separately. df into C, df into B, as we developed this formula above. DF into B and DF into C. Both of these are calculated separately. So the separate columns are calculated. This you can do easily by pausing the video. You have an experience now. So once we calculate these two columns, we are going to take their vertical sums to see their overall effect over time. This is the value which can be called as sum of discounted costs, and this is the sum of discounted benefits. Now, as per the formula, going back to the formula, this is the formula: discounting factor into B, take the difference of it from the product of D F, that is discounting factor into C. So this is these are the two columns that I have summed vertically, and now I will take their difference as mentioned in the formula. I'm using sum of discounted benefits and sum of discounted costs. It will be again NPV, net present value. The same answer should be there. So the sum of discounted benefits minus sum of discounted costs are giving us the same answer that we had before by using the other method. This is that value, it's the same value. So in this case we did the netting after multiplying, so it is known as the netting after method. Answer of it is the same. And in the previous case we did netting before, because we subtracted, we found the net benefits primarily, and then we multiplied it with the discounting factor. So it is the netting before approach, and this is the netting after approach. These are two approaches. The answer will be the same, and in the background we have this distributive property that is used in algebra. Now let's summarize this thing. Remarks are these, that if we do the netting before, it will be something like this, that over time we will take the difference of the two columns, that is benefits and costs, and then we will discount them with this factor, that is 1 over 1 plus I raised to the power t. This 1 disappears when multiplied with bt minus ct. So it happens over a series that is from t till n. Here the value of n is equal to 10 because there were 10 years. So this is the summation form formula of NPV. Netting after approach will be the same thing but in a different way. That is, benefit series is discounted primarily over time, and then cost series is discounted separately over time, and then it is afterwards it is netted or taken a difference of, which will give us the same value, that is NPV. So we expressed it in summation form. Finally we talk about the selection criterion. If we use this netting before approach formula, it is the same thing, answer will be the same. So we are using the netting before formula approach here. The answer of it will be either 0 or greater than 0 or less than 0, because it is the difference of the two values. Whenever we subtract two things, either we get 0 or a positive value or a negative value. If it is a positive value, it means that the benefits are greater than costs and it is desirable to undertake this project. If the answer is 0, it means that there is an equality of the benefits and the costs. And now we are indifferent. We are not sure if we should undertake this project or not, because the benefits and the costs on the whole, collectively from first till the last year after discounting, are appearing to be equal. So we can either go for the project or we can avoid the project. It all depends upon the severity of the situation. For example, if there is a project related to COVID-19 in current situation, no matter the NPV is equal to 0, we should undertake this project because this is the need of time. So severity of the situation can require us to undertake the project, even in the case where the project is inviable and the NPV is negative, that is, the benefits are less than the costs. If it is the matter of war, a project is to be undertaken, Yes, it has to be undertaken, and the NPV will not be the final criterion. The need or the severity of the need or the situation will decide. However, our technical knowledge guides the decision makers if they should undertake the project or not. And for that, using this criterion, that is NPV, it should be ideally greater than 0, positive. Otherwise, if it is less than or equal to 0, then definitely there are question marks. So in this video we have understood the very first discounted measure of project worth, and the name of that is net present value, and it is also represented with NPV, and this is the formula and this is the selection criteria of it, how we can select the project or reject the project, make the recommendation by using the final answer of NPV. Thank you.